So first, please plug in negative infinity in here and tell me where this is going. We always start from the inside. Where is this going?
Infinity.
Good. So now, where is natural log of infinity going? And you can look at the graph.
Infinity.
Excellent. And this will not change. If you put infinity or negative infinity in here, this is still going to infinity because this is squared. So I found the limits. Good. Of course, 0 has to be in the table. And I have to determine the y value. And I also have to determine f of x being 0. So remember, x and y intercepts. So f of 0 equals natural log 9. And I will approximate it in a minute. But also f of x equals 0. So natural log of x squared plus 9 is 0. What should this be for natural log of it to be 0? Or you can say, no, I don't want to think in those terms. I want to change it into an exponential equation. It's either or. You choose. If you don't remember how to change it into an exponential equation, say so and I'll show step by step. Can anyone give us the answer or tell us what I need to do? Anyone, please?
Wouldn't ln have to be ln1 equals 0?
Absolutely. Only natural log 1 is 0. The other way would be, since the base is e to 0 equals this. But e to 0 equals x squared plus 9 is the same thing, that x squared plus 9 must equal 1. Awesome, thank you. So then we have x squared equals negative 8. What are the solutions for x squared equals negative 8? Anyone? Tell us what the type of solutions are these?
Is it plus or minus root 8?
Say it again, Victoria.
I was saying we square both sides, and it's going to be plus or minus root 8.
Yes, you can take the square root, not square. Take the square root. But what type of numbers we get?
Not real numbers.
Thank you. So no solutions. So the only thing I need to determine is natural log 9. So I have natural log 9. Oh my goodness. Although I could have done that, but there was a different function in there. Natural log 9, what is it? 2.2. Fine. Okay, I found something. There's nothing else. This is done. We don't study the sign of the function, please. Only x and y intercepts and limits. Now I'll move on to the first derivative. Good. So again, I'm copying the function here, natural log of x squared plus 9. Can anyone give us f prime? Anyone? F prime.
Is it 1 over x squared plus 9 times 2x.
Awesome. So very good. Thank you so much. X squared plus 9. So f prime can be undefined, or f prime can be 0. Where is this function undefined? For which values of x is this function undefined?
Nowhere.
Excellent. Where is this function? Because x squared plus 9 is never 0. Excellent. Where is this function 0?
Zero.
Excellent. Thank you very much. Look at that. Nice. Good. So which portion of this function, which is the first derivative, you will not study the sign for because it will be a waste of time?
X squared plus 9.
Of course. So now pick a number to the left of 0 and give me the sign. Pick a number to the right of 0 and give me the sign. Only for the top. This is a waste of time.
For the left, it's negative.
Awesome. Now I'm having the moment of truth. I'm having a moment in which I check, right? So from positive infinity to 2.2, what does the function do?
Decrease.
Good. Is that supported by the sign of the first derivative? Is this what the function is supposed to be doing when the first derivative is negative?
Yes.
Yes. And of course here. What type of point is this? It may be absolute. Yeah, of course. Infinity to infinity, of course it's absolute. But for now, what is it?
The minimum.
Yes. Local or relative minimum. Perfect. Let's study the second derivative. Good. So now we differentiate this. I'll keep 2 outside. So my f prime is this, because it's a factor at the top. If I have plus 1, I cannot do that. But I don't have plus 1. And what will I do without my whiteout? Good. So the top prime is 1, x squared plus 9 minus the top times the denominator prime over the denominator squared. One more time. The top prime is 1 times the denominator minus the top times the denominator prime. Okay? See, my props are so valuable here. You should have your own props and cover this and that when you calculate something. It's easier. Okay. X squared plus 9 minus 2x squared, which is negative x squared plus 9 over x squared plus 9 squared. You know I am allergic to negative leading coefficients. I know that I have to factor the numerator. Can anyone give us the numerator in a factored form?
X minus 3 and x plus 3.
Brilliant. Thank you very much. Thank you. Good. So now I want the second derivative undefined or the second derivative 0. This will be a waste of time, of course. It's always defined. But when is the second derivative 0? Anyone?
X equals 3.
or -3. Very good. I found something. I found something. Have to find this value right here. But let's study the sign. Which portion of this you're not going to waste time with?
The denominator.
The denominator and this 2 in front. In negative x squared minus 9, please pick 0 and tell me the sign. Pick 0 and tell me the sign.
Negative.
Positive.
Perfect. It's quadratic, so if between solutions, if it's positive, outside will be negative. Or you just plug in -10. -10, this will cover, this will be positive with minus in front, or you plug in 10, this will be positive with minus in front, still negative. I know that immediately how the function looks like. This is expected. How do I know? Because this is a relative min. It cannot be do this and be a relative min. So this was clearly expected. And opening down. So the function has an IP here and an IP here. How do I know? It changes sign. It changes concavity. And it's 0 or undefined. It changes concavity. And the second derivative is 0 or undefined. But it's not enough. I need to find this number. Because the point -3 blah, blah, blah is the inflection point. And 3 whatever is the inflection point. Since the function is even, right, f of -x equals f of x, these two numbers have to be the same. So, because I plug in and I get natural log of 18, that's all it is. If I plug in -3 or I plug in 3, it's not going to make any difference. 9 plus 9 is still 18. So, let's determine natural log of 18. (2.9). How nice to plot 2.2 and 2.9. Awesome. 2.9. Done. This is it. That's all I care. Everything else makes no sense. I don't care for it. It doesn't mean anything. This is it. I don't want to look anywhere else. I don't need to. It will be a waste of time to look anywhere else. That's it. That's all I need. So, by the way, very good pick, Quinn. Thank you. Oops. This needs help later on. Okay. -3, 2.9. +3, 2.9. 0, 2.2. That's all the points I have. It's I don't like this. Oh, I like this. A little weird, but I like it. Good. Now I see. I thought it was, for a moment, I thought it was a mistake. Coming from positive infinity, opening down, decreasing to the inflection point. Fine. Get to the inflection point, changes concavity, reaching a minimum at 0, 2.2. Continuing to open up, increasing to 2.9. Changing concavity at the inflection point, going to infinity, opening down. and it has to be the same because it's an even function. And that's it. So this is f of x, natural log x squared plus 9. You can always, by the way, we haven't done that. What was the previous function? Yes, let's also graph both. Just to check, we should always, especially in a I didn't graph this with a graphing calculator, but I know the viewing window. I don't need to see everything. I need to see negative infinity to 6. So the viewing window should be negative 10 is fine, but I don't need to pass to go to that far to 10, right? Because from 6 on is not going to appear anything. So I'm going to change it to 8. I know the function doesn't go beyond 5.6, 5.7 as the maximum y, because we already graphed it. Negative 5 is good enough, but it doesn't go beyond 6. So I would say, okay, 8 is good enough, and then I graph it. And I know exactly what to expect. And no, the graph doesn't end here. So please don't trust the calculator. I'm not saying the calculator is a bad tool. I'm only saying you know more than the calculator does. So now you know that if on a test situation, let's say we get this problem to graph, and a student just copies till this point, then I know the student just copied from the graphing calculator, right? It's impossible. Because when I plug in 6, I get 0. But this is not what the calculator is showing. The calculator, the graph does not show 0 here. It shows that it stops at 1 or whatever, 1 point something. No, we know that that's incorrect. And now the last one that we just looked at was natural log of x squared plus 9. Was a very good pick. Thank you so much again. Okay, so when I graph this, I know the viewing window should be between negative 10 and 10 if you want. There is nothing under 2.2, right? So y minimum, yeah, I want to see the x-axis, let's say negative 1 to 15 with a scale of 5 or 3, doesn't matter really. And then I graph. But I don't want to see the negative side. I don't want to go to y minimum of negative 10 or more because I already have the graph. I know exactly what to expect. Here it is. The calculator does not tell me where the inflection points are. So it's opening down. Who knows where the inflection point is? I can't figure it out from the graph, but I already know because I did my calculations. So this is opening up between the 2 points of inflections, and we know they are at negative 3 and 3. But who can read this? No one, right? So we know because we went through everything step by step. So opening down, then at negative 3, and 3 has an inflection point, then it opens up, and then again opens down. And as expected, it's an even function, meaning you can fold this function with respect to the y-axis, and they will overlap both branches, right? So if I do this, my graph is not perfect. It will never be perfect. But if I do this, the 2 branches have to overlap completely because the function is an even function. So that's how we use the table, solely the table, nothing else. Don't look anywhere. Everything else is confusing. But you need all this work in order to fill in everything in the table. And one student had a very legitimate question, asked me, when do I know I'm done? When your table is completely filled up with inflection, with the critical numbers, the sign of the derivative, x and y intercepts, limits, the inflection points, and the signs of the derivative, or second derivative. Then you know you're done. And the sequence is always finish up this, find the first derivative, study everything, and then move on to the second derivative. It was a very good pick. Thank you. Any questions on this problem before we move on? How do you feel about this table and the analysis before we graph now? Is it coming along better? Gabby, thank you. Anyone else? Tadeusz? Okay, good. Okay, Quinn, awesome. We're going to have more, of course. So this is one of the major applications in this chapter. Okay, I'm going to share my screen now. And let's go to rational functions. So let's choose something with, you know, like something like, I don't know, 60 rational function, or we can make one up. Okay, just if you want to make up a rational function, or I can make up a rational function, or we can, as I said, we can choose from here. Anyone would like to choose?